Hi, my name is John. This is part 2. Welcome back to chapter 3 test, Trigonometry with Trig-Mckeague. I will be using the 4th edition, 5th edition, and 6th edition is pretty similar. So let's get started on number 17. 17 looks something like this. Find the tangent of 330 degrees. Okay, that's what we're looking for. Of course, it's in the 4th quadrant. 180, 270, 330 degrees. Here's the reference angle, 30 degrees. We're going to draw it up to make that 90 degrees. It's going to be negative 1, root 3, and 2. This is the most important thing, guys. Make sure you get negative 1 because it's going down 1 unit, going root 3 and then 2. The tangent is the opposite over the adjacent, which is equal to negative 1 over root 3. That's your final answer. Or root 3 over 3 with a negative. Number 18, we'll do number 18 too as well. The secant of 390 degrees. That's the same thing as a full circle of 360. Subtract that, you get 30 degrees, and we're going to try to find the secant of 30 degrees. Question mark. We draw it again. It does a full circle, and it goes up 30 degrees. Bring it on down to the reference. This is going to be 1 root 3 over 2. Secant is the reciprocal of the cosine function. Instead of root 3 over 2, it's going to be 2 over root 3. Or 2 root 3 over 3. Either one, you should get the same answer. Okay, that's just root 3 right there. Sorry about that. So let's get started with some parts of the other information. This is pretty important stuff. Unit circle. This is a review of a unit circle, which means that the radius is 1. You know that the circumference of the circle is equal to 2 pi r. Since the radius is 1, 2 times pi times 1, circumference is equal to 2 pi. In other words, if you go a full circle with the radius equal to 1, the circumference is 2 pi radians. So this outer length is going to be 2 pi. Of course, 360 degrees, we said that earlier, that's equal to 2 pi radians, divided by 2, 180 degrees is equal to pi. 1/2 of 360 is right over here. That should be pi units. Divide that by 2 again, 90 degrees is going to be half of pi, which is pi over 2. Half of 90 is 45 degrees, which is equal to half of pi over 2, which is pi over 4. Now we take this number, and what we're going to do is we're going to multiply it by a third. What's a third of 90? You get 30 degrees. A third of pi over 6 is going to be pi over 6. And multiply by 2 again. I'm going to use my marker for this one. Times it by 2. My marker just flew, excuse me. I don't know which one it was now. That's going to be 60 degrees is equal to 2 times pi over 6 is 2 pi over 6, which is pi over 3. I want you to memorize these because we'll be using them later on. So I'll show you an easy way to memorize this. This is the most important one. The pi is 180. 6 and the 3 interchange. 3 and the 6 interchange. The 4 with the 4 right there. And this is also pretty important. Pi over 2 is also 90 degrees. So 3 and the 6, 6 and the 3, 4 and the 4, and pi. So if you're having a little bit of problem, just stop, pause your button, and then make sure you write this down or go backwards. Rewind, review, rewind, preview. So let's look at number 19. This is the way I want you to do it. I don't know the teacher. I'd rather do it the way in the book. If you have degrees here, you put the degrees in the denominator. 180 degrees is pi radians. Just like right over here, 180 degrees is pi. I asterisk that. That's pretty important stuff. So make sure you get that down. The degrees cancel. If you're not familiar, just put it over 1 so that you know it's going to be 250 over 1. One of these cancel. 25 and the 18 does not cancel. You end up with 25 pi over 18 radians. Okay, so that's what you get. How about number 21 now? 21, what is the sign of, 4 pi over 3? You want to change it to degrees. So what you do is go 4 pi over 3, you multiply by 180 over pi, that's in degrees, that's in radians. The radians will cancel. This is radians. The pi's will cancel. The 3 will cancel to a 60. 60 times 4 is 240 degrees. There is a shortcut for this. We know that pi over 3 is 60. So I'm going to use my marker for this. That's equal to 60 degrees right there times 4, 240. Because it's a family of 30, 60, 90, or the 45, 45, 90, we should know that it's going to turn out to be 4 times 60, which is 240 degrees. Let's go on to number 23 now. 23 says, what's the sign of 2 pi over 3? Well, obviously, I'm going to use my marker for this again. Pi over 3 is 60 degrees times 2. That becomes the sine of 120 degrees. And we use the same thing again here. We draw it out. It's in the second quadrant. It's going to radiate like this. That's 120 degrees. That's going to be 60 degrees. And 60 is going to be, the short angle is going to be 1, root 3, and that short side, excuse me, and 2 is going to be the radius. Notice that this is negative because it's going in the left, in the x direction. So it's going to be negative 1, positive root 3, and the radius is always positive 2. So what's the sign of that angle right here? Opposite of a hypotenuse. That's going to equal root 3 over 2. That's your final answer. Approximately 0.866. If you use your calculator, take the sine of 240 degrees, you end up with negative 0.866. Okay? Let's do number 25 now. 25 says, number 25 says the following. 4 cosine of negative 3 pi over 4. And we're trying to find out what that is. Okay? How do we figure out what that is? Well, we know that pi over 4 is 45 times 3 is 135. It's going to be 4 times the cosine of negative 135 degrees. That's the same thing as from radians to degrees. Let's draw it out, see what it looks like. We're going in the negative direction, whereas we're going in the positive direction, negative 90. Negative 135 is located right here. So that's 135, negative. So this is going to be 45 degrees. That's our reference angle. We bring it straight up. And we're going to have to see what a 45 degree angle looks like. It's negative 1, and root 2. Again, you notice that? It's negative 1 in the x direction, negative 1 in the y direction. Of course, this is going to be a 90 degree angle. So what's the cosine of that angle? It's going to be adjacent over hypotenuse. So it's going to be 4 times negative 1 over root 2. Same thing as 4 times negative root 2 over 2. It cancels. 1 and a 2. Negative 2 root 2. Use the reference angle all the time. And here's a little thing that comes out of how that works. Can you actually see that circle that's forming? So all these triangles are within the circle, and so you're going to have to know how to use a unit circle anyway. It's going to be very, very helpful. You know the first quadrant, that's the most basic one. Second, third, and fourth as well. Okay. Let's look at number 29. Evaluate 2 cosine of 3x minus pi over 2 when x means equals pi over 3. So we're going to substitute pi over 3 in here. That means 2 times cosine of 3 times pi over 3 is pi minus pi over 2. What's pi minus pi over 2? It's the cosine of pi over 2. That's the same thing. Pi minus pi over 2 is the same thing as 2 pi over 2 minus pi over 2. You end up with one single pi over 2. Cosine of pi over 2, that's going to be 90. So we take the cosine of 90 times 2. What's the cosine of 90? It's the x direction or the y direction. I'm sorry, the radius direction. Here it is. That's the 90 degree mark. X is equal to 0. at 90 degrees right here. So 0 over anything is going to be 0. So it's going to be 2 times 0, which is 0. That's for number 29. Let's do 31. This is pretty important stuff, so I'm going to have to show you how to do some of these even and odd functions. By definition, this is a definition of an even function. F of negative x is equal to f of x. Think of it as magic right here for an even function. The negative actually literally disappears. I'll give you an example of that. If you take the cosine of negative 45.97, that should be the same thing as the cosine of 45.97. You can use your calculator. I'm pretty sure you'll get the same answer. Okay? So in the even function, the cosine actually disappears. Let's get odd functions now. Definition of an odd function looks something like this. F of negative x is equal to negative f of x. In other words, the negative comes out to the front, that's where it ends up. Okay? Let's do an example of that. The sine of negative 5.97 should equal negative sine of 5.97. Okay? And you can use your calculator, verify it. You can use any number you want. If the negative comes out, these are equivalent. Okay? So number 31 says the following. Show that the cotangent is an odd function. So the first part, that means prove. The first part is the most important part right here. I'm going to do this on a new page so that you'll actually see it better. So it goes something like this. This is the most important part, guys, so make sure you get this down. Show that the cotangent of negative theta is equal to negative cotangent of theta. That's what we're trying to prove right here. The cotangent of negative theta, and the negative comes out because we know that these are odd functions. So we have to manipulate the left side only. The only way we're going to do that is change the cotangent into the sine and cosine function. So it's the ratio of the cosine of negative theta over the sine of negative theta. And that's going to become cosine of negative theta. We know that the cosine is a even function right over here. It's even function. So therefore, we're going to say that's equal to cosine of theta divided by the sine of negative theta. We know that it's an odd function. The negative actually comes out, becomes negative sine of theta. From this portion right there, cosine over sine is the cotangent of that angle. And the negative comes out to the front. Wow, we checked it. QED, quadratus demonstratum, and thus we have demonstrated. So let's do one that's a little bit more difficult. I'm going to get some more paper out because I'm running out of paper here. And so let's try to work it out with some other problems. Let's look at, I'm going to use this pencil, I'm going to use this one. 32. Prove that sine of negative theta